This time we'll be working on wedges, pegs, mortices, and the chamfer for the hayrake. So we've got a small miter fence set up to cut our wedges for wedging the tenons. It's basically got a track that runs in the right side of the table saw here. A little piece of plywood with a kerf cut through it, and that's where our kerf is going to be. It kind of acts as a zero clearance fence, which is kind of nice. We're screwing it down on one end. Our wedge will go from this point down to this edge here. This edge here where it catches. And we've got the angle set so that we have wedges that end up being about 3/16 of an inch at the fat end and go all the way down to the 0 point at the other end, and that are long enough for our bigger wedges. So we're going to make some dowels, and we've got a piece of iron that he's just drilled a couple different holes in, going down in size, 1/2 inch, 3/8, 5/16. We could go smaller down to 1/4, but we're not doing that. We have some pieces of stock that we've cut to a square that's, what, about a 1/2 inch square?
Less.
A little less, so that it's inside the 1/2 inch, but outside of the 3/8. So he's just pounding it through those. Start with, he's going to chamfer these edges. We could make it easier by also taking off these square corners a little bit. Nice roundish dowel that we can use for pegging our drawboard. A pencil sharpener works better for this. This is making walnut dowels. We've got some cutoff for making the splines, which is a little bit bigger than 1/4 of an inch square. We're going to chuck that into a drill. Drill it on down. Now that's putting a square peg into a round hole. And for the remainder, he'll tap it through and take it down one more size. And if you wanted it smaller than this, of course, you'd just keep on going. To get vibration, just slow down a little bit. Better yet, reverse the drill to back the dowel out. Now the advantage over hammering the whole thing through is you're not smashing up the end of your dowel. You get a really nice smooth dowel, and it's a whole lot easier. So without using a drill press, we're using some verticals to be able to watch which direction we're holding the drill. And we're putting a little block in to keep it from going all the way through. We've marked the holes opposite on both sides towards me. A little bit more towards you a hair, right there. Towards me. That's fine. So you can watch what he's doing vertically side to side, and I was giving him the second, lining it up with the square. And we're marking the position for the draw bore by inserting the drill bit into the hole, just tapping it with the point going in. We have a 45-degree clamp, so we know it's the way it's supposed to be. Cleaned up the shoulder a little bit, and we'll take that out. Okay, so our mark is right there. And we'll take our punch.
It's right here.
And mark 1/16 of an inch to the inside of that mark that we just made. You want to make sure that you're not going to the wrong side of it, because otherwise you're actually pushing your tenon out instead of pulling it in. So we went towards the shoulder with the 1/16 of an inch. and we'll drill that.
I didn't capture any video of the glue up or pounding the drawbores through, but this is the end result.
Today I need to widen out the mortises to be able to accept the wedges in the through tenons. So that's just a matter of tapering out just a little bit. I've got 3/16 of an inch wedge that I'll be putting in. So I'm making my angle about 1/8 of an inch on each side. So I'll be starting at just a little ways inside, right at the base of this pencil line here. And I'll be taking that just straight down to the table, just to where it touches, so that I don't get beyond the shoulder that I've already established on the other side.
Because of the back angle, I widened the mortise from the inside to the outside on this half.
Check it periodically. So I think you can maybe see it. I still have a little bit of an edge here. That's not gonna, it's gonna keep my tenon from coming out as far as I want. I want to get that a little bit closer.
The other half of this mortise can be widened from the outside to the inside.
Yeah, that's good clean walls for my exterior wall. Pretty happy with that. Nice straight lines. That's what I'm after.
Here's the completed joint. Everything is drawbored and wedged.
I want really crisp lines on the outside where I'm putting in the extra angle for the wedges. This one's a little bit easier to do. It's straight down instead of at an angle, and it's the width of my chisel. So it's going to be a lot easier to manage this. So I'll just start here and go almost straight down. When you line up your chisel, you can see the reflection of my line in the chisel back. That helps me keep it straight to that line as I go closer and closer, and always trying to see a little bit of my chisel line until I get to that final paring by hand to take that last line down. Not vertical like this wall. I want it only a slight angle about what my wedge is. It's hardly any at all, just a little angle like that. The original Barnsley Hayrake Table has stop chamfered edges on all of the base parts. When Barnsley did it, he used a draw knife to do his. He didn't use anything else, not a spoke shave or anything else. We have a router, and I don't have my flat spoke shave here. I don't have a draw knife here. So we're using what we have, a router with a 45-degree angle bit. To make sure that we stop the chamfers in the right places, we're going to just eyeball it on all of these tape lines. For our table, we decided on about a 1 1/4 inch chamfer setback, stop chamfer from each of the corners. And we'll get everything taped up and do both sides. We're going to do it before we insert the legs into the ends, because it's going to be a whole lot easier managing the chamfers at this time.
A bearing on the bit keeps the cut consistent. For a controlled cut, it's important to move from the left to the right on the edge that the bit is against.
For the placement of the cross members, I needed first to make sure that the distance between the legs at the base was the same as it is at the cross member top part. Then I've marked on each piece the outsides of the leg where that is, and then transferred the stub tenon on the inside to the cross member. And then I'll cut that out on the table saw, clean up this, and it should sit down nice and tight before I actually do the pegging down here for the legs, to make sure everything snugs up the way it needs to be down there vertically. That'll help my hold the legs vertically in line as I mark them. Out here on the outside, I have markings. I've decided to put the stretchers outside of the legs simply because I have about a 3 or 4 inch overhang on the tabletop on the outside here, outside of this support. And I wanted to make sure that that first board, the first really full wide board, would be pulled down for the length of the table, and that should hopefully help prevent any sagging in the center of the table as well. Having 2 stretchers Originally, I was thinking about putting just one stretcher in the very center of each of these cross pieces, but I've decided that two is a much better idea. The reason I decided to go outside rather than inside, right about here, is where I had originally thought I would put them, but that would only space them about 2 feet apart on a 4-foot wide table, leaving a foot to the outside where the table doesn't have any real support. Wanted to make sure it had very, very good support end to end, especially since I'm looking at a 7.5 foot long table.
The top crossbar is dry fit, the legs are held square, and the hay rake is glued, drawboard, and wedged.
I'll just plane the edges flush on all of these wedges and then sand everything down smooth with the leg. It's going to be a good table?
Yeah,
We hope so.
I like it.